Assalamualaikum warahmatullahi wabarakatuh. Hi guys. On this video, we want to explain to all of you about number theory, especially about the Euclidean algorithm. Before that, let me introducing ourselves. We are from second group. My name is Nur Rahma and my friend Hafiza. For the first, Hafiza will explain to all of you about the greatest common factor, about the least common multiple, and about the Euclidean algorithm.
Greatest common factor, or we call GCF, is the greatest positive integers that divide the two integers. For example, find the greatest common factor of 2 and 6. Factor of 2 are 1 and 2. Factor of 6 are 1, 2, 3, and 6. Greatest common factor 1 times 2 equal to 2. Least common multiple, or we call LCM, is the smallest number that divisible by both integers a and b. For example, find LCM for 2 and 6. Multiple of 2 are 2, 4, 6, 8, etc. Multiple of 6 are 6, 12, 18, 24, etc. Least common multiple is 6. The Euclidean algorithm for any integers a and b with b greater than 0, there exists unique q and r such that a equal to q times b plus r and r greater than or equal to 0, r less than b. In Euclidean algorithm, there are lemma and theorem. And now, I want to explain you about lemma of the Euclidean algorithm. First lemma, let a and b are elements of integers with b greater than 0, then GCF 0b equal to b. Second lemma, let c and d be integers, not both equal to 0. If q and r are integers such that c equal to d times q plus r, then GCF CD equal to GCF dr. Theorem of the Euclidean algorithm. First theorem, let a and b be integers with b less than a, b greater than or equal to 0, then GCD AB is the only one natural number d such that d divides a and d divides b. If k is an integer that divides both a and b, then k divides d. And next, we want to explain you how to solve problem greatest common factor and problem least common multiple by using the Euclidean algorithm. When we use the Euclidean algorithm, we use the Euclidean algorithm when the problem asks for the biggest nominal. For example, compute the GCF of 580A and 2030. Divisor of 580A are 1, 2, 3, 4, 6, 7, 12, 14, 21, 42, 49, 84, 98, 147, 196, 294, 588. Divisor of 2030 are 1, 2, 5, 7, 10, 14, 29, 35, 58, 70, 145, 203, 290, 406, 1015, and 2030. DCF is 14. And then we use the Euclidean algorithm when the problem is complicated.
And now let we solve the first problem, that find the greatest common factor for 124 and 52 use the Euclidean algorithm. Yeah, as I have told and I have explained about the Euclidean algorithm that for any integers a and b with b greater than 0, there exists unique key and r such that a equals to key times b and r greater than or equals to 0 and less than b. Now let's we imply it in this problem. First, 124 equals to 2 times 52 plus 20. That 20 greater than or equals than 0 and less than 52. 52 equals to 2 times 20 plus 12. That 12 greater than or equals to 0 and less than 20. 20 equals to 1 times 12 plus 8. That 8 greater than or equals to 0 and less than 12. 12 equals to 1 times 8 plus 4. That 4 greater than or equals to 0 and less than 8. And the last, that 8 equals to 2 times 4 plus 0. And we find a 0, so it's end up. So the greatest common factor for 52 and 124 is 4. Okay, now let we continue to the second problem. Okay, on the second problem, say that find the greatest common factor from 843 and 321 use the Euclidean algorithm. Yeah, we will solve this problem with the same method that we used before. Okay, let's get started. 843 equals to 2 times 321 plus 210. That 210 greater than or equals than 0 and less than 321. 321 equals to 1 times 201 plus 120. That 120 greater than or equals than 0 and less than 201. 201 equals to 1 times 120 plus 81, and 81 greater than or equals than 0 and less than 120. 120 equals to 1 times 81 plus 39. That 39 greater than or equals than 0 and less than 81. 81 equals to 2 times 39 plus 3. That 3 greater than or equals than 0 and less than 39. For the last, 39 equals to 13 times 3 plus 0. So we find the greatest common factor from 843 and 321 is 3. Okay, now we will discuss about how to get the least common multiple with the Euclidean algorithm. Yes, to solve the problem about the least common multiple with the Euclidean algorithm, we have the formula that the least common multiple from A and B equals to A times B divided by greatest common factor from A and B. Next, The third problem. Find the least common multiple from 52 and 124 if the greatest common factor from 52 and 124 is equals to 4. Use the Euclidean algorithm. The answer is the least common multiple from A and B equals to A times B divided by greatest common factor from A and B. Okay, now the least common multiple from 52 and 124 equals to 52 times 124 divided by 4. That equals to 1612. Okay, it will be the last problem that we solve together. And thank you for watching this video. Hope you like it, and don't forget to subscribe, like, and turn on the notification.